Hello people, so today we'll be solving LeetCode daily question, that is 840 magic squares in grid, and in this we'll be having a 3 cross 3 magic square, and a 3 cross 3 magic square is a 3 cross 3 grid filled with distinct numbers from 1 to 9 such that each row, column and both diagonals have all the same sum. Okay, and we'll be given our row into column grid of integers and how many 3 cross 3 continuous magic square subgrids are there. And note, while a magic square can only contain numbers from 1 to 9, grid may contain number up to 15. Okay, so for example we are having this particular grid of 3 cross 4, and this is one 3 cross 3 grid which forms a magic square. As you can see that 4 plus 3 7, 7 and 8 15, 9 5 14 plus 1 15, 2 7 and 6, this the row sum comes out to be 15. Now if we'll check the column sum, that is 4 and 9 13, 13 and 2 15, 3 and 5 8, 8 and 7 again 15, 8 1 8 plus 1 9, 9 and 6 15. So the column sum and row sum are matched, but this is not just enough. The diagonal sum should also be equal. So we are having this diagonal 4 5 and 6, these sums up to 15, and 2 5 and 8, these as well sum up to 15. But if you'll check for this will not give me a magic square because the sums will not be equal. Okay, if I'll just give it a try, 4, yeah. So here I have 4 and 8 12 and 3 15. Okay, so, oh yeah, if we will see this diagonal only, so 3 plus 1 gives me 4 4 and 2 6. So this does not form a magic square, because if it is a magic square, then the row sum, column sum and the diagonal sum should be equal. Okay, so for this we'll be needing a kind of sliding window, but sliding subgrids we can say. So let's have a answer variable that is initially 0, and then let's run a for loop that for, okay, for int I equal to 0, I less than grid dot length minus 2 I plus plus. And similarly for the j, for int j equal to 0, j less than grid 0 dot length minus 2 j plus plus. And then we'll be checking that if we get if is magic square, we'll be passing on the coordinates, basically the grid as well, grid my I j. If this comes out to be true, I'll be incrementing my answer, and at the end we'll just return answer. Okay, now let's quickly write this function. Private boolean is magic square. In this we are having grid followed by row, current row and the current column. Okay, now let's have a few variables and also scene variable, scene array, boolean scene, that is equal to of new boolean of size 10, because we like if we are having any number which is greater than 10, and if we are having columns, then it like if anywhere the value is 10, so it wouldn't be possible for us to form a magic square. Okay, so let's have some variable, and sum of, okay, row sum 1, that is equal to 0. Similarly I'll just copy this. Okay, oh, my bad, paste and then paste here, it should be this, row sum 3 and row sum 2. Similarly I'll need to have column sums as well. Okay, call sum, uh, column sum, oh, I'll just do it, ah, oh, oh, okay, row sum 2 it is, that's why I call sum, and again the column sum. Then similarly diagonal sum, and sum diagonal 1, that is equal to 0, sum diagonal 2, that is equal to 0 again. Okay, now we'll be traversing in the grid. So for int I equal to 0, I less than 3 I plus plus, then okay, for my bad, for int j equal to 0, j less than 3 j plus plus. Okay, we'll be checking that the current number firstly, that will be equal to grid of I plus r and j plus c. Okay, now we'll be having some checks that if number is less than 1, or number is greater than 9, or we have already seen that particular number, seen num, we will just do a continue and we will not add that number again. Okay, now we will be checking that in which of the column we need to add that, in which of the variable we need to add that. If I is equal to 0, so we'll be adding it in row sum 1, row sum plus equal to num. Okay, similarly I'll just copy this for 2 and 3 as well. Oh, yeah, so if here my, oh, the row sum 1, now if I is equal to 1, in that case row sum 2. Now if I is equal to 2, I'll be adding it in my row sum 3. Similarly I'll need to do it for the j as well. Okay, so d, yeah, if j is equal to 0, so here call sum, again here column sum, and here again column sum. Okay, now in the case of diagonal sum, what we'll have to do is that we'll be checking that if I is equal to j, in that case we'll be updating it in the sum of diagonal sum, or sum diagonal or diagonal, so yeah, sum of diagonal, sum diagonal 1 plus equal to num. Okay, and then if I plus j is equal to 2, in that case we'll be adding it in sum of diagonal 2 plus equal to num. Okay, and at the end we'll have to return a lot of things. Basically we'll be checking that if, oh sorry, let's just do a direct return. The variables are row sum 1 should be equal to row sum 2, which should be equal to row sum 3. Okay, oh sorry, and I forgot to control C, yeah, and row sum. Okay, now further, and I'll be writing it in the next line. Column sum 1 should be equal to column sum 2, and column sum 2 should be equal to column sum 3, and sum diagonal 1 should be equal to sum diagonal 2, and sum of diagonal 2 should be equal to 15. Okay, now let's give it a run. Yeah, and it gets accepted. Now let's submit it. Oh, okay, so it failed on one test case. Okay, I'll just like go through the code again. Oh, okay, so I don't know why, but here we need to add another check that all these values should be equal to 15, but I don't think so that should have any other effect. Should be equal to 15, and call someone should be equal to 15, call some 2 should be equal to 15, and call some 3 is equal to 15, and sum of 15. Okay, now let's give it a run again. Oh, let's submit it. It will get, okay, so I guess I made some other mistake. Now let's just I guess I'm updating a variable wrong at some place. Call some 1, call some 2, call some 3. Okay, if num is greater than 9, okay, so this is fine, or I've already seen num, and oh, I forgot to mark the scene of num equal to true. Now let's give it a run again, and now let's submit it. I never updated that. Yeah, and it gets filled, and it works probably fine as well. Okay, so this was for video. Thank you for watching.